Okay, welcome. We're analyzing graphs of motion once again. You've been using motion sensors in lab. You've been looking at the position time graphs. And the question today is, how do we analyze not just the average velocity using a position time graph or displacement versus time graph, but also how can you draw its velocity time graph and how to analyze the slope of that. So consider this first scenario. Let's assume that this graph showing you the change in your position over time over 6 seconds is illustrated at the start. In the first segment, you walk away 2 meters in the first 2 seconds. So you can see your slope, which is your rise over your run. It shows that you have moved 2 meters in 2 seconds for an average velocity of 1 meter per second. Again, measuring the slope algebraically of this graph will always guarantee units of meters per second, which are units of velocity. So the slope represents your average velocity during that time interval that you are analyzing. In the second segment, you are at the 2 meter position to start, and 2 seconds later, you're still at the 2 meter position. So you have traveled 0 meters in 2 seconds. Therefore, you are not moving at all, standing still in the second segment. And finally, in the third segment, you start at the 2 meter position, but you end back at the 0 meter position. So you have fallen 2 meters over 2 seconds. So again, your displacement includes direction. So it can be a negative 2 meters backwards compared to in the first segment you traveled positive 2 meters forward. You've now fallen 2 meters over 2 seconds. And if you remember in algebra class, anytime the slope of the line points downhill to the right, it's a negative slope. And algebraically, you notice that the rise is negative 2, the run is 2 seconds, negative 2 over 2 seconds is a velocity of negative 1 meter per second. So you have just figured out the average velocity of your walking motion as you walk this path here, analyzing the slope of these 3 line segments 1, 2, and 3. Traveling 1 meter per second, that's positive in the forward direction. You're standing still, and then you're traveling negative 1 meter per second. That negative denotes direction, so we can say that's backwards or towards the sensor. All right, now if you know your velocities in each of those 3 segments, now you can start to look at a graph analyzing your average velocity over the same 6 seconds. So the challenge for you is to draw your graph displaying your change in velocity over the 6 seconds if this was your walking motion. So you'll have 3 segments, segments 1, 2, and 3. And if you think of those segments, let's just divide this graph up. What are you doing in the first 2 seconds? What are you doing between seconds 2 and 4? And what are you doing between 4 and 6? So what are you doing in the first segment? What are you doing in the second segment? And what are you doing in the third segment? Well, your answer is over here. We've already solved it. Your average velocity in the first segment is 1 meter per second. So if velocity is on your y-axis, and you're traveling at 1 meter per second, and you're constantly traveling at 1 meter per second everywhere along this slope, because this is a linear slope, which is constant, you are always moving 1 meter per second for the full time interval in that first segment. You have this little horizontal line showing your velocity of 1 meter per second the whole time. But then you suddenly stop, time 2 seconds. You suddenly stop. 0 velocity. And you remain stationary for the next 2 segments during that entire interval from 2 to 4 seconds. So you were moving at 1 meter per second, and now you pause and stop at 0 velocity for the next segment. And then finally, at the very end, you start moving again, except now your velocity is in the negative direction, which just means that instead of moving forward, you're moving backward. You've changed directions, but you're going at 1 meter per second at the same speed, just in the negative direction. So at time 4 seconds, you are now moving at a constant velocity of negative 1 meter per second. And you can also now ask the question, well, if this is the velocity, graph that represents your position versus time graph, what do the slopes of these line segments mean? Well, all of these line segments are horizontal line segments, and you remember the slope of any horizontal line is always zero. You're guaranteed the slope of each of these lines is zero. But what does that mean? The slope means the change in your y-axis variable, in this case, the change in your velocity, divided by the change in your x-axis variable, in this case time. And by definition, change in velocity per unit time is acceleration. That means anytime you're analyzing a velocity versus time graph, the slope of any line segment will always represent the average rate of acceleration. So while the slope of a change in position versus time graph or displacement versus time graph always represents your average velocity during that time interval, the slope of a velocity versus time graph will always represent your acceleration. And in this case, the slope is always 0 meters per second per second. In other words, your acceleration is always 0 meters per second. In other words, 0 meters per second squared, because you are never rising or running on any horizontal line segment.